Whilst it is true that computers can only make simple decisions, it is also true that asking lots of simple questions in the correct order enables complex systems to be constructed. A major assistance in this technique of programming is the ability to nest one if statement inside another, so that the nested if statement only gets executed on either the true or the false branch of the parent if statement, and we saw this in the previous example program. Structuring questions correctly then becomes necessary to ensure that the resulting code is efficient and only asks each particular question once. Consider a situation whereby the mark a student is given, between 0 and 100 for example, equates to a given grade depending upon its value. There are several grade bands to apply, for example a pass at 40, a merit at 60 and a distinction at 80%. When we look at such a situation, we can apply the appropriate grade by asking a single complex question. We might then refer to a table of grade bands to determine the answer, but this process, to us, feels straightforward. However, as computers can only ask simple questions that have a yes or a no answer, we cannot ask a question such as what is this student's grade. We need to successively ask questions such as has this student achieved a pass, or has this student achieved a distinction, to be able to determine what the exact grade is. If care is not taken when writing a program such as this to perform complex processing, you might end up either asking the same question multiple times, or perhaps worse still, assigning an incorrect grade. There is usually an optimal solution to such problems, and in this case a logical thing to do is to start from the lower end of the grade bands and successively determine if a student is in that band, and keep going until you find out which band they are not in. Then the band immediately below the band that they are not in is the band that they have achieved. Alternatively, you could start at the top of the band and work down. The first band that achieves a match is the one that the student is actually in. Which method you choose will depend upon which potential answer will be best for the majority of cases, so that your solution is the best in the majority of cases, and we will return to this subject later in the course. For now, let us assume that the method of working up through the bands is the best. The first question we should ask is whether or not the student has achieved 40 marks or more. If they have not achieved 40 or more, then we can output their result as a fail. So if mark is less than 40, then result equals F. And then we can move on to the next student. If they have achieved 40 or more, then we will need to work out whether or not they have reached the next grade band. So if mark is less than 60, we know at this point that it has to be greater than or equal to 40 because the first test failed. So therefore we just need to check if mark is less than 60. We can then output the result as a P. The next question to be asked can then move on and check to see if the mark is less than 80. And if it's not less than 80, then we can go on and check to see, well, it must be a distinction. If it is less than 80, we know, because it failed the previous two tests, that it is 60 or more. So therefore it's somewhere between 60 and 80, which means in this case that the result is a merit. The final else condition is if the mark then is not less than 80, it therefore must be greater than 80. So we can check to see if the mark is valid. Is it less than or equal to 100? If it is, then the result is a D for distinction, else the result is an E for error, for example. So this is a complicated, or a reasonably complicated nested if statement that allows us to carry out some fairly complex processing.